Good morning, class, and welcome to this lesson on Circuits 12, terminal voltage and internal resistance. Today we will be able to define and calculate the terminal voltage and internal resistance of a battery in a circuit. Okay, so let's define these terms first. Batteries, like students, are lazy. Batteries, like students, batteries have an internal resistance. Okay, so in essence, a battery in reality is a resistor. A battery is also a resistor. Okay, so if we drew a basic circuit diagram, like this, okay, the battery in itself is also a resistor. So to draw a more accurate representation of this, we would draw this. Okay, this resistor representing the battery. Okay, so all batteries have some form of internal resistance. There's some amount of energy that goes into making the battery function. Okay, it's a very, very small amount. So all batteries have an internal resistance. Okay, so there's going to be a lot of times in problems you're going to see it's going to say there's no internal resistance. What it's talking about is don't count the resistance of the battery, okay? But in reality, if we're trying to get a very accurate number, we need to count the resistance of the battery itself, okay? And so because batteries have an internal resistance, they have something called a terminal voltage. There's something called a terminal voltage, and this is going to be the actual voltage of the battery. The actual voltage of the battery. So let's say, for example, we have a 9-volt battery. We have a 9-volt battery. It says 9 volts right here, okay? But the battery offers an internal resistance. So this 9 volts is the EMF, okay? It's that weird looking E there. This is the maximum possible voltage. This is maximum possible. The maximum possible is the EMF. But the reality is because of the internal resistance, the actual voltage or the terminal voltage, I'll put TV for terminal voltage, the terminal voltage might be like 8.9 volts because the battery is offering some resistance in itself, not even connected with the circuit, okay? So the EMF is the maximum possible voltage and the terminal voltage is the actual voltage, okay? So let's do a problem. Here's a picture of a battery. It's showing you right here that little r, that's big R. Little r is the internal resistance right here. And we're going to say the internal resistance of this battery is 0.010 ohms. So little r is 0.010 ohms, and this is a 12-volt battery. You can see it's a pretty simple example here, okay? So in this example, we want to calculate the terminal voltage. We want to calculate the terminal voltage. Okay? So this is going to lead us to an equation right here. Okay? We're going to have the actual voltage. I'm going to call actual voltage. Okay? Or the EMF minus the actual voltage minus the voltage due to internal resistance. You know, IR is not a good thing to do. Due to internal resistance. Okay, so our actual voltage minus the voltage due to the internal resistance will give us our terminal voltage. Okay, and so I'll do voltage actual or the EMF minus voltage due to the internal resistance is going to equal the voltage terminal. Okay, so our voltage for this battery, the voltage that it is rated at, the EMF, is going to be 12 volts. Okay, how many volts is going to happen here? How many volts are we going to lose to internal resistance? Well, in this problem, we're going to state up front that this is going to flow at 10 amps. Okay, it's flowing at 10 amps, so that has to be given to you. So we know that V equals I times R. Well, I is equal to 10 amps. R is equal to 0.010 ohms, and this is going to equal our terminal voltage. 10 times that is going to equal zero point 0.1, so we're going to have 12 volts minus zero point 0.1 equals our terminal voltage, which is going to be 11.9 volts. So this is our terminal voltage, and that is our internal resistance. Okay, so you might get any number of problems like these, but if you remember this equation right here, that we have our EMF voltage, the voltage that it should be rated at, this is the maximum possible, minus the terminal voltage, or minus the internal resistance voltage, it'll equal our terminal voltage. If you remember this basic setup right here, you should be able to go back and forth and solve for pretty much any equation with this type of setup.